Still there.
Let me see.
That's
There, finished product.
Good Scott.
Yeah,
He is the whistle.
yeah, yeah,
Next one next door.
yeah. There's the ramp that's not quite done.
One board short.
Yes, I look
Isn't that
like
great
I'm really
looking
mad
guy?
at the ramp, you know?
He's
Yeah,
starting to look
like
like
Rada.
Einstein there or something.
Yeah. Look like I need a haircut, that's what I need. Yeah,
That looks,
That young guy.
profile.
yeah.
I get pretty stiff.
Oops, we'll pass it over. Yeah, this is the first ramp, the first day when there was power washing and built the ramp in. You can see the green. Oh, yeah, you can see some of the green.
Very happy.
You can see he just got this one little corner done, you know.
Now we gotta get
At
that.
that point.
Spray for all the rest of the building.
You could use
There
the
we
power
go.
washer on the 16th.
Um,
Oh, boy.
that's in my house. I got a new register or whatever. Okay.
We need to move on.
Okay, this is, remember Tom said, NGC 6960?
Uh-huh.
That was part of the Western Veil Nebula. And some of you may have seen this image posted. Phil has it up on the web, among some of the things that the rest of us have. And I'm pretty proud of it. It's one of the prettiest pictures. But yes.
From last Friday.
Again,
This from last Friday. Last Friday night.
no, this is from 2019.
Okay.
Okay.
So it's been up and it's there. And it really is a pretty picture. It's a work of art when you see it, on the screen. But, in a way, the picture's kind of lying to you. What's important is the stuff that's not showing. This is taken with a Nikon D55 camera, and it's an off-the-shelf camera. And a lot of those cameras have a filter put in it that cuts out some of the lower frequencies. And I don't know the technical reason why, but apparently it makes it easier for them to process and do it with the pictures in the visible range that we want a camera to show. But I found I could get around that, went online and I found a camera, a Nikon D810, which is a bigger format camera than this. This is what the chip is what they called maybe what, a 3/4 size from the standard 35 millimeter frame that we're used to. The D810 has a full screen 35 millimeter format, which means it can capture a large amount. It's kind of hard to see in this. There's a little bit of red nebulosity down below in there.
Mhm.
But basically, so to my delight, I found last Friday night that the D810 has indeed done its work. So now we're going to quit this. I may need your help again, and I'll show you the D810.
Sometimes.
I just click that up or quit sharing.
Oh, yeah.
And now go back
Yeah.
and go back to access stock. No,
That one?
the same one,
Sorry.
same one. And now we're gonna pick up D810, right there, the one above it. Much better picture.
Oh, yeah.
Oh, yeah.
Look at that. Whoa, wait. What do you mean? Much better picture.
We can't see it.
Thing looks like
You're not
garbage.
sharing. Gene, you have to,
Wow.
Jim, you have to share.
Have you got it?
No.
It's got to share.
Wrong one.
Okay.
Wrong one.
That's the one.
No.
No,
that's the first one.
First
One might be the
Yeah.
other one.
That's the first.
Okay, but, okay, wait. This is the first one?
That's the one you want right
You
there.
want this, the one with the red?
Yeah, yes.
Okay. Oh, no, I closed the shared window.
I love them windows.
There.
Yep.
There you go, you can see a little more red.
Yeah,
Okay. I got you.
Can you see it now?
yeah.
Is that a different folder?
This is with the blocking filter removed. But the picture looks horrible, at first sight, even though it's a better picture. And the reason is because, the camera is set at 90 degrees, so really, north is to the left, south is to the right. And, you're going to see a lot more of the area in the red. You can see why it's been called the witch's broom, because the red looks like some of the straw of the broom there. But there are a lot of things wrong with this image, obviously. If you look at the one at the portions on the left, some of the stars are pretty much round. Look over to the far right. There's nothing around there. They're little star changes. They're strict star trails. That means that the telescope was not polar aligned
Mhm.
properly. That's field rotation, is what you see. Now, the nebulosity software has a way to correct that. It takes a lot more time to process it down and stack the images. This is the result of 80 images. I recorded 100 and threw out 20 of them. Just the first quick processing. There are a lot of things wrong here. The stars are bloated. And what can be done is remove the stars earlier and then process the nebula and then put the stars back in. That's a technique that Phil has talked to me about. I need to talk with him about how to do that again. But obviously, this is a photograph I would never want to see online. And hopefully, for those of you who, if you're recording this session, I don't know if there's a way to get rid of that.
Clip out what we don't want.
Clip that portion. I don't want to show this in public because there's a lot that has to be done to it. So, but at any rate, it does show what the D810 camera can do.
Sure.
And I'm ready to pass on the baton.
No. So you leave me
Yeah.
with 3 minutes, but that's okay.
Oh, we got one.
Thank you, Steve.
We'll turn the clock.
We got 3 minutes.
Let's get it.
I know.
Let's get this out now and
Joe,
eject
sorry,
this.
figure it out.
Maybe.
He's quick to stop.
Just a minute.
Yeah.
He's
I'm
familiar.
Yeah.
Sure, cash got
Yeah, there you go.
24.
Oh, they also sent it out that if you want to apply to this, are you the license? You're not the local district, are you?
Yeah, he's got
Who is local district?
There are a lot of zeros there.
What happens, what happens after he dies?
Hopefully, hopefully someone else click off.
Full cover document.
There's gonna be a,
I'm just asking.
hey, sorry, Charlie, on there.
I think he's.
How was it, is that?
I think you're not right.
Yeah, that's his.
Did you need it to check?
Hopefully he's got dark
I
hair.
don't
not
see,
gray hair.
I don't see an eject option.
Uh,
It
just-
seemed like after 8 or 10 years, they just, okay, you can have it. Yeah, just whatever they do.
Then just pull it out, dude. Still smoke came out, so that's good.
Industrial engineer.
Which way does this go? Not that way. Yeah, not that way. Oh, there we go. All right. Yep. There we go. Got to see me.
Yeah, I think there's like a really small.
Humiliate myself here.
Drive.
All right, now Gene was complaining that he would never show his in public. And I have to say that this is a real anxiety-ridden kind of effort, because he was talking about his not being particularly pretty or proper, and well, that's the case here as well. So I have to actually start screen sharing. Do I have to have this? Do I have to have this showing, or? There's just, I don't want to share that.
Just click, yeah, then just click on them.
And then where's this share screen?
Right there, the green button.
Oh, there we go. Share. All right, so I am not even pretending to be almost a good astrophotographer. This is a first effort at M31, and you can see some nice detail in all this. By the way, this was taken on my 5-inch Starfire on an AP 400 mount that does not auto guide. So this is all just with the tracking of the scope. I did use a sharp cap to do polar alignment on it, and so I think it was pretty good. And this particular image was not particularly long, so star trail shouldn't be an issue as by second single exposure. So, you know, the good parts are you can see dust lanes, you can see M110, it's a little squashed, and the center is burned out. I don't really know how you're supposed to control burning out M31's core, but everything I tried didn't really work, so this was one of the better ones. So it's an effort, and this image does feature all three of the calibration frames. So I've got a bias frame that was subtracted out. I've got a dark frame and a flat frame in order to make it look as good as it does here. So no tomatoes, no rocks. This is just the first efforts.
No, I'm glad you're up there.
So this is what you can do when you don't know what you're doing.
But you did.
And this is a stack of 10 frames. You know, same thing. All of the frames, sharp cap was taking care of the subtraction of all the frames and the flat fielding. So that was good there. And the only thing I really did to this was change the display points, the black point and the white point to make it show up a bit more of the dust lanes. So I could have tried a mosaic, but I think it would have been a waste of time.
What camera did you use with that?
This is the one ASI 178 mono, obviously. So
Did
this
you
is
have a
just
focal reducer on
it might have.
there? I'm just surprised.
Either these stars are elongated because of the focal reducer, or it was field rotation. But I thought I had a good polar alignment, so I like to blame the focal reducer. I may not be right about that.
I'm just surprised you got that big a field of view with that camera.
It's an f6, a 5-inch f6.
Right.
And then I can't remember, I didn't write it down, so I'm not sure if I had it in there or not. Okay, a little better. I think it works out better if the field is sort of uniform in its light distribution. This is M52. This is M52 one frame, 16 seconds. So dark frames, flats, all that good stuff there. So this one doesn't show any of the star distortion. So I think this is without. I think the other one was with the 2-to-1 reducer, and this is without. So the stars are a little big here and there, but I kind of like this one as an early effort. I guess it's okay. It'll have to do. The next, I believe, is probably getting into spectroscopic stuff. No, it's the sun.
That's a good shot.
It's the sun. So this is with the my hydrogen alpha telescope, my 80 mm Lunt. It's an F7. This is with the focal reducer. Since I had the mount up for taking the pictures that we just looked at, it's nice to put the solar scope on and be able to track the sun and take images. The eye is a wonderful imaging tool. The range that we can see, the dynamic range of the eye is really good. With the same, just viewing it, the naked eye, the prominences that you normally see around the edge are easily seen in the telescope. But in order to get the prominences to show up, you really have to kind of overexpose it, and it sort of burns out the middle. But this one does nicely show a good amount of filamentary activity up here at the top. You got filaments all over the place here, lots and lots of filaments. And you've got some plage areas. Sometimes the plage areas are actually flaring. Not in this case, they're just bright regions. And on this day, in this solar max, we only had one visible sunspot over here on the right side at about 4 o'clock. So kind of interesting, a plage area around it, nice black umbra, and a filament basically emanating from it. So pretty cool. So like I said, in order to get the prominences to show up, you have to kind of overexpose. This one is probably a little overexposed, but it's interesting to see the prominences, the various shapes. These are basically connecting into the coronosphere and are actually draining material back into the sun, which is kind of neat. So a normal kind of a set of prominences. Nice little bitty hedgerow up here at the top. But this must be the spectroscope stuff. Yes. So in the last month, I've been doing a lot of work with the spectrograph, and I've been getting familiar with the 1200 line grading. It's a high resolution grading. The 600 grading has a resolution of about 2000. The 1200 grading has a resolution with the 23 micron slit of close to 6000. So it's a very high resolution grading. And what I was doing here was an exercise to figure out what the micrometer settings need to be in order to walk across the entire visual range of the sun in this case, but just of light. So starting out at 3800 and ending up at just over 7400 angstroms, you pretty much cover the entire visual range. These are the K and H lines. And a variety of others. This over here is water. This is tellurics, Earth's atmosphere. The three at the bottom are micrometer settings that allow you to focus on just the Balmer lines. So H alpha, H beta, centered up as you can see, and then because gamma and delta are fairly close together, you can get those. So this comes in handy. I have line libraries for it now, so I can do my calibrations more quickly. Also, equations are available if I want to just do a quick look with some suggested wavelength numbers. They're not necessarily close, but they at least help isolate it. And so this it's been real busy getting onto the 1200 grading. The software that put all this together was VSpec. And then the real point of the exercise was to actually get at the hydrogen alpha line. The spectroscopic group I'm in is studying a star called, and it has a real catchy name. You'll like this. It's very memorable. HD 5501. It's in the constellation of Cassiopeia. It's near the bright star in the middle of the W, relatively near. And we're told by the astrophysicist that wants us to look at this thing that the key to this star is understanding how the H alpha is changing. it's a spectroscopic binary, and it's exchanging matter from what is it, a red giant, I think, or yeah, and it's stealing material off of that, and there's a hot spot that's moving around. So the light curve, we just saw a lot of light curve demonstration with Tom. And so the light curve for this particular spectroscopic binary shows all sorts of variations. And he'd like to write a paper on this. So the group that I'm in, he asked to go and get spectra of it so that he could try to figure out what's going on.
You'll get a credit in the article.
Actually, I would if I submit spectra, and I do plan to. So this is just an illustration of the differences between the different types. So G2, a K1, and an M 1.5. And if you look at this line, you can see that it actually is changing quite a bit between the three different types. So this kind of change in various lines can be used to classify the stars, to figure out whether they're a G2 or a
That
K1.
1200, what's your pixel angstrom readings?
About 0.3. So it's pretty good. Pretty good. Let's see what else. So this is from last Friday, I think, whenever the 16th was. When was the 16th? This is the first spectroscopic image of 5501. It's 3 20-minute exposures, so 1200 seconds of exposure here. And this image also has all of the calibrating frames, put to it, dark frame, flat frame, and a bias frame taken out of this. And in addition, there's another processing element that goes into this, the instrument response correction, which corrects for various defects in the camera, the optics, the sky for that night. And so it helps. One of the reasons that it's looking flat like this is because of the instrument response correction. And this is a B-type star, so it's fairly hot, and there really isn't a whole lot going on in the blue side or on the red side of hydrogen alpha. A little bit of silicon here and a little bit of silicon there. So not sure what he wants to look for. He was saying that he would prefer moving to the blue rather than having the H alpha centered. So he wants to see more of the blue side. And this is the reference star 3360. This is, oh, by the way, this one is an 8.8, basically a magnitude 9 star. That's one of the reasons for the need for 2 hours worth of data. This one's a 3.3, and so it only needs 3 minutes. And if the star is actually centered properly on the slit, I could do this in 1 minute exposures. So the instrument response curve is this thing at the bottom, and so you take this and divide it into your regular spectra, and it does all these corrections. So kind of a neat tool. The ISIS software package does all this. Actually, the ISIS package will take all of the stars. So if I have 3 exposures, it will process them, do all the dark frame and flat framing and all of that stuff, and it will also do the instrument response curve correction. It will do the wavelength calibration for you automatically. It will take all of the images that you have and stack them and create a spectra that's actually derotated and then stacked. So instead of having any sort of a curvature, not curvature, but angle on it, it will take that out and you get these beautiful spectra. So
What is that software?
really amazing. ISIS. Yeah. So, and then this is just what I'll show Dr. Gray as far as what the difference in the wavelength range can be. This top one is one of the images of the sun, and this one starts a bit more into the blue side and ends just beyond H alpha, as you can see. And this image down here is the H alpha image that we just looked at, and you can see how much further into the blue if we went with this 9.6 millimeter diffraction grading setting versus the 9.36 to get the H alpha line. So the sun shows a whole lot more lines, a whole lot more interesting things in it than it's it's a G-type star, and so it's a bit cooler and has more of the absorption lines that you can see, probably more chemically seeded with all of the materials, all of the elements in there, but definitely a cooler temperature in the G. The instrument correction was not applied to the sun, so you see a bit of this wavering in here from that. So all of this within about the last 6 weeks or so. And these are just better images of the sun spectra. So
Great.
yeah, these are all ISIS based images right here. So anyway, so that's what I've been up to with the spectroscope and my dabbling in astrophotography. So
Cool.
there you
Very
go.
good. A lot of hard work in there.
Yeah, really. In fact, the star that's in Cassiopeia, this 5501, I didn't even think the telescope would get to it. With the spectroscope mounted, the spectroscope obviously will run into the fork, run into the base of the fork if you go up very high.
Right.
If, for example, we can't get the Polaris with it, and this star sits at 60 degrees of declination and some change. It's just under 61. But if it was at like 61 or 62, probably wouldn't be able to get it. You can't really go any higher than what this star is. So it's really lucky to be able to get there. And so I'm able to participate in this effort because of that. So lucky me. Cool. That's all I had. There, now everyone can see what I'm talking about. So what ends up happening is when you focus it in this area up here, you get a little dot, and then it turns out that you get varying amounts of light filling this area here, and you get a little hot spot down here. You also get a little dot here, but you can hardly see that one. And so if I change the white setting, I can get this boiled down to the point where you can actually see the hot spot, which is right here. And I was very puzzled as to why the 3366 star was giving me really good intensities for a couple of exposures, and then immediately fell off to 10%. I mean, it went down by, 6. Went from 64% down to about 10%. And I believe that was because the slit was actually operating above the hot spot. It was operating like here or higher, and it just wasn't getting as much light just because of the inaccuracies in the guiding. So I need to try to hit this low point. Luckily, there's a pointer. This dot tells me that I need to be over here, and so I can go from there. And the other thing that caused me a great deal of grief was the go to again. And so it put me in the general neighborhood, and I was able to identify 2 sets of stars that would allow me to star hop into the object of interest. So, and HD 5501 is not in the database. It's just not there. So I tried putting a user object in, and it doesn't let you go into seconds. It just takes minutes, degrees, minutes, no seconds. So it turns out, I think what I need to do is to use this HIP 4404, this star here, try to go to on this, and then star hop my way in. And I did that. I did that Friday, and after some searching and trying to figure out how to do this, and it actually worked quite reliably. It turned out all I needed to do was to move it south. I only had to move in one direction. I went straight down, and I was able to confirm 5501 using the plate solving software that I've got. So, hallelujah. And here's a picture of the scope in the same position it would be in looking at the 5501. And you can see it's standing on its head. And on the right side here, it shows just how close it is to running into the base or the bottom of the fork. So, wow, lucky. And it was actually tracking quite well that night. So I had guiding errors of like 1.2, 1.3 arc seconds. So that's actually really good for this telescope. Now I'm done.
So,
I stopped sharing.
You have to give permission.
Yeah.
Yeah,
There you go.
I don't know, that looks,
we're there.
that looks good.
sharing, okay.
Yes,
Yeah.
All right, so I've migrated away from my DSLR camera, and I finally bit the bullet and got myself a dedicated chilled astro camera, and this is an ASI 6200. It's a full frame imager, and unfortunately, when I first started using it, the user interface for the software for the capturing, the fonts are so small with my poor vision, I couldn't see it properly, and I thought I had set it to minus 20 degrees Celsius for the chilling. Turns out I missed the minus sign, and I was actually just shooting it at 20 degrees C. So all my first attempts were not even using the chilled camera. So, but anyway, that's I don't know. Can you see my mouse moving around?
Yeah.
Yeah.
Okay. So this is my Tech 140. This draw tube comes out. This is a dedicated field flattener here. And to give you an idea, this is about 4 inches, the draw tube on this telescope. And it needs to be this large to be able to properly illuminate a full frame sensor like this one. And then these are the various adapters and spacers that are needed to go from this field flattener over to the ASI camera. And then for me, something brand new is this little compartment right here. And this is a filter drawer. And I'll tell you, now that I've started to use filters, no going back without them. It has helped so much with the light pollution. It's not even funny. My light pollution here has gotten really bad. To the north, the light dome from Fort Wayne extends up to at least 50 degrees high, maybe 60. And so things have to be pretty much directly overhead for me to be able to shoot. Now, let's see if I can try to get rid of, I think I really dorked things up here. I have to do it. I'm trying to figure out how to make this image. There we go. There we go. I'll make it bigger. But I can't see what's happening is on my screen, I'm seeing pictures of all the Zoom members on the right. But anyway, that's just a close-up of the imaging train. So let's see, where do I start? I don't know. I'll just start with some pictures. This was my last picture. This is the bubble nebula, and all of these pictures that I've taken are unguided right now using short exposures. So my next step will be to start guiding again, and once I get back up into 5, 6, 7 minute exposures, these images should get substantially better. So let's see, this area here, may recognize it. This is Seder. And kind of always been fascinated by Cygnus and Seder, and these dark veins just fascinate me. You can just zoom up. These images here, by the way, are reduced in size by a factor of 5 already. The camera has almost 10,000 pixels across horizontally, and I've reduced these down to just 2,000. So as you zoom in, of course, you're going to start seeing pixelation, but I just love imaging these and just kind of scrutinizing these dark veins and just having fun with them.
Oh, yeah, I got them. I got
Let's see what so this one here. Yeah, so when I was shooting the bubble nebula, this was right in the center of my frame. And since it's a full frame camera, I basically had to throw away 3/4 of the picture. And when I cropped it out, this was in the lower left, and I just thought to myself, gosh, that's kind of a neat area, a pretty combination of hydrogen alpha clouds, and then we've got these white clouds here, which I'm not sure. I tried to look up to see if there was any kind of designation, but it's directly across from what's known as the salt and pepper cluster. So anyway, I kind of thought this region was interesting, and I was just going to throw away when I cropped this image here, I was going to throw that away, and I thought it might make an interesting picture. So here's
Dennis, could you go back to the bubble and just zoom in on that real quick? Just
yeah.
awesome. Thanks.
Yeah. The
There's a t-shirt.
yeah, to zoom in, it's what I should have done is left these in the original size. Like I said, this has been reduced already by a factor of 5. So I've only got 2,000 pixels to show this. And with my telescope, I've got such so little focal length. I have very little magnification, and this isn't a very big object. So I had to do a lot of cropping to be able to see this bubble. My telescope only has a little over 1,000 millimeters of focal length. So if any of you guys want to use you've got the 16-inch there, this would be an ideal object to image with that. This is my take on a portion of the Eastern Veil Nebula, and I really enjoyed processing this. I always had difficulty bringing out the oxygen emissions from this, but using this camera and using the filters now, I'm using a dual band filter for this. It really has made quite a difference. Here I went ahead and imaged the Crescent Nebula, and this pretty much is a full frame. This is uncropped in any way, and I thought it was really cool to see some of the oxygen emissions glowing around the crescent itself. And then I just had no idea that it was surrounded by all this hydrogen alpha to begin with. So what I did is I took the same data and I just cropped it, and I to get kind of an enlargement. So this is kind of cheating. I'm using digital zoom, if you will, but still it kind of fascinated me to see these oxygen shock waves or whatever they may be, and all these twists and curves, and kind of looks like a brain. I don't know. Now let's see what else we got here. So this was M101, and this was right after I got the camera, and I happened to catch the supernova, which you can see right here. And that was a lot of fun. And again, these are pretty mediocre because they're unguided exposures, and they're short. I mean, they're only like a couple of minute exposures, and I'm stacking, I don't know, maybe 30 of them. So all of these are about an hour total. This was M66, I believe. So pretty,
Yeah.
very, very pretty galaxy. There's my M33. I took probably about a month ago. And what was nice for me was to finally start seeing all of the hydrogen alpha that's hidden in the arms. And that's something that I have not been able to capture previously. And then the details, like I said, in the original image, the one that's got almost 10,000 pixels across, I was really pleased how far you could zoom in and see the dark veins, dust veins in front of that. This is one that I took, oh, I don't know, probably about 3 weeks ago, M27. Again, unguided exposures. And a lot of people, when they image, they like to reduce or eliminate most of the stars in the background. I kind of like seeing different colored stars, so I left them just the way. I didn't do anything to attenuate the stars at all, but I was quite pleased with how much detail I was able to capture with a small telescope, like 140 millimeter. The detail inside was really kind of cool, and then the emissions outside of the nebula was actually the first time I've been able to ever capture that. Anytime I've imaged M27, I've been able, of course, to get the main shape that everyone's familiar with, but I've never been able to capture this outer glow. So that was kind of a really cool surprise. This is M13, and this was taken before I had the cooling enabled, so this was a lot noisier than normal. But what was really, really cool was to capture a lot of the hot blue Cepheid stars here. And what's neat is if you image them a day later, you'll see that, of course, they're pulsating, right, getting darker and brighter and darker and brighter, and they do that on a regular basis. So, And what's neat is there was a lot of detail. The more you zoomed in, of course, we got the galaxy hiding. Well, I don't know if you are you guys able to see the galaxy up there?
Yeah,
Yes.
Okay, now when I zoom in like the way now are you able to still see it?
yeah,
Okay, see on my screen, I can't because I'm seeing all of the Zoom participants, so I can't see the entire right side
Yeah.
the way you can, so, okay. Um, it'll be interesting. I plan to go back to some of these images and I'd like to see how faint some of the stars are and actually hunt for some of the quasars that are around these objects. And I'd like to do a comparison to what I was able to do with the DSLR. Here. So this is the Elephant Trunk Nebula, and I'm not quite sure why they named it that. I guess this is the elephant trunk. Now, I myself, doesn't matter how much bourbon I've had, I can't make out the elephant trunk, but maybe I need more bourbon, but somehow people see an elephant trunk. But I again, I enjoy.
Oh, there it is.
That looks like an
Yeah, there it is.
elephant.
You got the cursor on the trunk right now.
Yeah.
Oh, is this it?
Yeah.
Oh, here, see, I thought somehow this was,
Oh, that's a babe right there.
okay.
really.
Oh, my
I
goodness.
don't know, that looks like a Dracula or
Looks
something.
like a Rorschach.
Oh, man, you
I
guys,
don't, that's the trunk. I think,
Honey up above there.
I don't know. I agree. I don't know where the trunk is.
See what you see. Okay.
Yeah, depends on your mood.
Yeah.
yeah,
That's a camel. That's a camel.
all right.
All right.
Good enough.
So this is the Pac-Man, and again, I really just enjoyed processing this one and leaving the stars in, and thought that turned out pretty nice.
Yeah,
ISIS is just missing.
that's one important shoot, man.
So this is of course, the Pelican, and what was interesting is I thought, okay, here's obviously the eyeball, and for the last 30-40 years, I always thought, like, here's his beak, long beak coming out here, and this is his eye, and here's his body. But people have been saying that no, it goes off to the right. Now, so which is it? Is his beak here or is his beak on the left?
Oh, it's left.
Yeah.
That's what I thought.
If you rotate the image like 90 degrees or so, otherwise it looks like a pterodactyl going to the right.
Well, yeah, exactly. Much more than a pelican, but given the orientation that it is this the beak here going to the left?
That's my opinion.
Okay, is like I said, some people say it goes to the right, and I thought, gosh, this looks like an alligator snout more than anything.
I guess I got to the right, yeah, Pelican got that.
Oh, man.
So this area in here, as I was processing this, I thought this is kind of cool. So what I did is I cropped out an area, this region in here, and I just kind of did it, and I really enjoyed this. So this one, there's just so many cool dark veins and features in here.
How'd you do the Orion Nebula?
The camera, what is allowing me to do this compared to my DSLR this camera uses very small pixels. It's using 3.7 micron pixels, and that's well under half the size or 1/4 the area that my DSLR pixels are.
Before credit for the camera.
So
Got some
Hard drive. Yes, hard drives are cheap.
so anyway, that's what I've got here for you.
That's great. Yeah.
Thank you.
Great.
There, get it.
Yes, that's great. Real good.
Yeah, wow, it's wonderful. Excellent.
I'm glad you liked them. Thank you.
Yeah.
Very nice.
About ready.
Good to see you too.
Yeah.
Good to see you.
Thank
Yeah.
you. Thank you.
Is your vision okay? You were having vision problems before.
Yeah, the vision is continuing to deteriorate. That's like I said, I was operating the camera, and all this time I thought I was running at -20C, and I was actually running it at 20C because I can't make out the minus sign. I can't see small details, so that's been kind of problematic. But yeah, after a couple of months, I figured it out.
Wow, it's actually heating. It's actually heating.
Torch on it.
Thank you, guys.
Yeah.
Thank you very much.
You're very welcome.
Yeah.
Travis?
Yeah, I think we're about ready to pull the plug on this meeting. It's been great. We had a lot of good stuff. Good speaker. I think it's been a very excellent meeting.
Yeah, a lot of people missed a very good meeting tonight. Oh, you got it.
Yeah.
Thanks.
Say hello to Julie.
Who actually attended? We never, from on Zoom here, we can't see who's in attendance. Who's in attendance?
Oh, you should be able to, but you were there. Phil is there.
We had about 18 here, 18 or 20 here, and about what, six
On the Zoom
on Zoom?
Yeah, you had.
Yeah, well, I can see the Zoom members, but we can't see the people that showed up in person. That's what I was curious.
Hit the lights. We'll all wave to you, okay, man?
I guess there we go. Okay. Hey, there we go. Hello, everybody.
Yeah, good turnout too.
Cool.
Get us.
Hey, I know that guy. I see him at his picture at the post office.
Yeah, I just started my new job there, Okay.
Thank you, everybody.
All right, good night.
A lot of fun. See you guys.
All right.
Take care, Phil.
Take care.
Bye-bye.
Okay, bye.
I don't know. I just couldn't tell. So you can buy it. You can buy it once.